I'm on the class examples handout, but I pasted into my document this visual. So you'll want to have this visual handy with all of the percentages. And let's talk about how to use this. So in the first example, and sorry, I didn't leave you a lot of space. I actually just spaced this document out for the purpose of my demonstration. But anyway, in number one, you probably do have enough room at the top of the paper. Draw yourself a normal curve. All right, and this is how you label your normal curve. You're always going to be given the mean. Okay, so we're looking at weights of newborn babies, which is something that's normally distributed. So you always put your mean right in the center. And then you're given standard deviation. So that's how you mark your diagram off, right? By adding the standard deviation as you move to the right-hand side, right? So this would be one standard deviation above the mean, right? So just add 20 to that, so 125, and then two standard deviations above the mean, 145, and virtually no one ever gets to the 3 standard deviations above. That would be 165. Okay, and then we go in the other direction. So this is 1 standard deviation below the mean. So subtract 20 from 105, you'd get 85. Here we are at 2 standard deviations below the mean at 65. And then virtually no one is down at 45 or lower. Okay, but what we can see by looking up above is that 68% have to fall with 34% on each side, right? 68% have to fall within 1 standard deviation of the mean, right? So there's 68% in here, and then there's 95% within 2 standard deviations. Right, so that's 95%. And then that would leave only 2.5% to be greater, right? Because remember, it's 100% under the whole thing. Okay, so, and then only 2.5% less than 2 standard deviations from the mean. Okay, and then we just start answering the questions. All right, so I could expect 68% of the babies to weigh between, oh, whoa, I'm sorry. And that would be, sorry about that. That would be 85 and 125. And what percent of the babies would weigh less than 125 ounces? Okay, so to figure that out, if I came here, less than 125, all right, maybe I'll look up here. Less than 1 standard deviation above the mean, right? There would be 16% above. The whole curve is 100%. Okay, so then what percent would I expect to be from this point and below? With 16% this way, right, that would leave me with 84% on the other side. Okay, so 84% less. And less than 145 ounces, right? That's practically everyone, because this is 2 standard deviations above. There's only 2.5% that weigh more than that, which means when I go in the other direction, if I take 100% and subtract the 2.5%, right, going this direction down, I would get the 97.5%. I'm sorry, I'm having trouble writing with this. What percent lie between 65 ounces and 145? That one's pretty easy. That's at the 95%. And there should be percentage signs after all of these. It's just so hard for me to write those with this. And between 105 and 125. Okay, so 105 and 125, I'm talking about just from here to here. So since there's 68% within one standard deviation, but I only want this part, right, from here to here. Okay, so that's going to be 34%. And then in between 65 and 85. Okay, so just in between here. This is between one standard deviation below and two standard deviations below. Okay, so if I come up here and look on my chart, right, I'm within here, which would be the 13.5%. So let's do one more together, and then I'll pause and have you try one on your own. So number 2, we're talking about IQ tests, which again is something that's normally distributed. All right, so the first thing you want to do is draw your bell-shaped curve. And your average goes right in the middle. Okay, and then you want to go out one standard deviation above, two standard deviations above. A lot of times I don't even ask you about, you know, three away, but we'll put it on our chart anyways. One below, two below, three below. Okay, so you're adding 15. And then going in this direction, you're subtracting 15. So that would be an IQ of 85, IQ of 70, IQ of 55. Okay, percentage of the population greater than 130. Okay, so going this way, more than two standard deviations above. Okay, and so again, I can click back to this. More than two standard deviations above, right? That is my 2.5%. Greater than 100. Okay, so what's from here up? This is our mean and our median. Right, so this, let's see, so this would be 2.5. Greater than 100, there would have to be, since that's our median, right, and it's halfway, that would be 50%. Okay, between 85 and 100. So that's in here. Okay, so if we go back up to that other diagram, each half here had 34%, right? Because within one standard deviation, we had 68%. So each individual section here is 34%. Between 70 and 130. So here's our two standard deviations. Right, so that's our 95%. Um, 55 to 145. So that's within 3 standard deviations. So that's our 99.7. Okay, less than 85. So let's see, I've got 50% here. I've got 34% here, right? 50 and 34 is 84%. The whole thing's 100, right? So if I do 100 minus 84, that leaves me with 16%. Okay, so 16% less than 85. And between 100 and 130. Okay, what I can do to figure this out is I have 95% from 70 to 130, right? And I have this symmetry. There's the same amount on the right as there is to the left. So if this has to be 95%, then I can split that exactly in half to get the 47.5%. Okay, if you didn't figure it out that way, you might have looked at this and said, okay, what percent is between here and here? Right, well, I've got 34, add that to 13.5, and that's another way to figure out the 47.5%. So the next thing I want you to do is pause the video, try number 3. Okay, so if it's a standardized test, it's likely normally distributed. When it's not a standardized test, and there aren't large numbers of students taking it, you know, classroom tests are virtually never normally distributed. So get this set up, right? The 74 goes in the middle. Get this set up and pause the video and come back and check your answers. Okay, if your answers all check out, then go on to number 4. As we mentioned, the amount of time that tires will last is typically normally distributed. This is what you should submit for today's participation. If you had any trouble with this, hang out for a minute and I'll go over it. So this should be 85. This should be 96. 63, and 52. Okay, so 68% of the scores, that's a pretty basic question, right? That should be within 1 standard deviation of the mean. Okay, what percent of the scores are expected to be just on this half between the 63 and the 74? All right, and so since the 68 is split exactly in half, there's 34 on either side. And we did do some basic percent review at the beginning of this course. So I hope it wasn't too difficult for you to take the 500 students and within positive and negative 2 standard deviations, that's 95%. Okay, so just multiply that by 0.95 to get the 475. Okay, what percent of students scored between 52 and 63? So maybe you wanted to go look at that diagram again, right? This is between 2 below and 1 below, which this section had 13.5%. Right, we can just take those values right off the diagram. And scoring above an 85. Okay, so if I go this way, okay, there's 50%. Let me change colors to contrast it. There's 50% this way, right? There's 34% from here to here. There would have to be 16% then from 85 and above. Although that's not what I asked you, right? I asked you what would be the value that would have the same percentage below, right? And because of the symmetry in this curve, right, I would have to from here down see 16%. And so that's where I got the 63. Okay, so thanks for hanging in all the way to the end to watch me go over this. And hopefully you're feeling comfortable enough to go on and work on number 4.